we're looking at what's called first order linear recursion relationships, as we discussed the other day. In particular, this one that we're looking at is linear recursion relationships that have what's called a common difference. So in between each of the numbers that we are generating as part of this sequence, it's going to have the same, it's either going to be adding on the same value or it's going to be subtracting the same value. So it's going to have the same difference, the same gap in between each of them. Now, the good news is when we are looking at creating these, the value that we're going to use for creating a common difference is D. It says here, in the old days where I'm from, arithmetic sequences had a common difference. Yep. So if you look at old books or whatever, and they're talking about arithmetic sequences, they're talking about recursion relationships that have a common difference, like we're looking at today. So it says here, consider the sequence. We've got 3, 7, 11, 15, and 19. Hopefully you can see there that there is the same difference between each of those numbers. They're adding on 4 in between each of those. If you look between 3 and 7, it's a difference of 4. 3 plus 4 is 7. If we're looking at 7, 7 plus 4 is 11, etc., etc. I think you guys are getting the hint there with that. So in this particular case, the common difference, D, is equal to 4. Perfect. It says this sequence may be defined by a first order recursion relationship using the following rule. In this case, we've got un plus 1, take away un is equal to 4. So this is, remember, it's the next value, take away the current value, is equal to 4. But notice they're also telling us over here as well that the starting value, in this particular case, is 3. So u1 was 3. And if you look at the values that we're generating over here, you can see the first one is 3. If you look at the next value, so in this case 7, 7 take away the 1 before it, which is 3, is 4. Yep. So in this case we have got, oh, we had a visitor behind us. Alright, we had a 4 between each of those there. Alright, now, a few things that you need to know. It can be rearranged as well into this particular format. You can have un plus 1, so the next value is equal to the current value plus the difference. So that is just this one over here rearranged. Oops, sorry, not that one. It's just this one here rearranged. Yep, that one there. Now, what you need to know is when you are finding out a value of D, which is the common difference, if the value is greater than 0, so that is, it's a positive number, that means the sequence is going to be increasing. It's going to be getting bigger and bigger. On the other hand, if you have a value of D that is less than 0, that means it's a negative number. It means it's going to be going down. It's going to be a decreasing sequence. Alrighty, first example is here. It says express the sequence, we've got 7, 12, 17, 22, and 27 as a first order recursion relationship. Alrighty, first thing I would do is just show you that I label this one here, U1, put in U2, U3, U4, and U5. So we've got all those labeled. First thing we need to do to make sure that we are dealing with a common difference recursion relationship is to actually make sure that the difference between each of those numbers is the same. So I'm going to say here, first thing is to check the difference. Alrighty, so checking the difference here, we'll do 12 take away 7, 12 take away 7, the difference there is 5. Let's check the next one, 17 take away 12, the difference here is 5. 22 take away 17, surprise surprise, the difference is 5. 27 take away 22, the difference is 5. Good news here is hopefully you've realized that the difference between each of those is 5. If you had to document that, I'd actually write it down. Difference between, for example, U4 and U5, or U3, sorry. Difference between that one and that one, 22, take away 17, to show that it's 5. You could do the next difference and find out difference between U3 and U2. So U3 was 17, that was 12, it's 5. Let's just check one more as well. Can never be too sure, even though we already knew this, as I explained. U2, take away the one before, it's 5. So we should be fairly confident there that the difference, the D value, is 5. So I'm going to write down that there is a common difference. The common difference of 5. Also, when we're dealing with a recursion relationship, you do need to specify what the starting value is. So in this case, the starting value, the first term is 7. So the first term is 7. Good. Once we've got these facts, we can use this rule that we've got up here. So un plus 1 is equal to un plus the D value plus the difference. In our particular case here, the next value is equal to the current value plus the D, the difference. In our case, we just worked out that the difference was 5. So it's going to be plus 5. But also, don't forget, number one rule with recursion relationships is you have to actually specify what the starting value is. So after this equation here, we're going to write down that the starting value, I'm going to call it U1, the starting value was 7. That way we've got a recursion relationship actually listed there. Alrighty, the next example. Oh, look at this technology moving up. Okay, cool. It says here, express the following sequence as a first order recursion relationship. You've got un equals -3 n take away 2, and we've got n equals 1, 2, 3, 4, 5. Hopefully you've realized it's not actually in this particular format that we've done before. This is a first order recursion relationship where it's specifying obviously the next value in the current value. It's actually saying what the starting value is as well. At the moment, this isn't a first order recursion relationship, so we need to change it into that. So at the moment, it's saying, hey, we're going to check the values for what happens when n is equal to 1, 2, 3, or 4, or 5. There's no easy way of doing this other than we need to actually work out what the value is when each of these occurs. So we actually have to find out what's happening when n is equal to 1, 2, 3, 4, and 5, etc., etc. Okay, a little bit painful, but you guys in further maths are up for the challenge. Alright, let's find out what's happening when n equals 1. So when n equals 1, obviously it'll be u1 from this here, is going to be equal to -3 times n, so times 1, because n is 1, take away 2. Simplifying this down, that is -3, take away 2, that is -5. We move on and we go and do n2 now. So again, repeating the process, we've got u2 is equal to -3 times the n value, which in this case is 2, take away 2. And we've just got to keep on doing this for each of these values. U3, got that there. I'll do one more. That'll give us enough information. -3 times 4, take away 2. Oops, that's a 2. Equals 14. Cool. So now that we've got the values, I'm just going to write what we had here. We had -5, we had -8, we had -11, and then, oops, sorry, this should be -14. -14 in our sequence. Now that we've got these values, we can go ahead and work out the first order recursion relationship. So remember, we need to see if there's a common difference between each of those. So let's check here. To work out the common difference, let's do -8, take away -5. Yep, in this case the difference here is -3. Here, difference between -11 and -8. Oh, common difference is -3, -3. Cool. I'm fairly confident to write down that there is a common difference of -3 between each of these. Cool. That's the first part of information we need to write a recursion relationship. The other thing is we do need to write down what the starting term. And we've also got that the first term is, you should be able to fairly clearly see that it's -5 there. Alrighty, we've got the common difference, we've got the first term. We can use this formula from above to write out this recursion relationship. So un plus 1 is equal to un plus d. So actually writing it out, un plus 1 is equal to un. Our difference in this case was -3. So you don't need to write plus -3. Hopefully you know as mathematicians in year 12, if you've got plus a negative number, it's just the same as the negative value there. So d is -3. Don't forget, and this is where people make a mistake with further maths, is they get a bit carried away and get a bit excited. Oh, better move on to the next question. No, we haven't finished our first order recursion relationship. First order recursion relationship has to have the starting value so you know what's going on. So after that, we need to say what the starting value is. So I'm saying u1. In this case, the first term was equal to -5. So we know where to start with that.